गाइस, तो आज हम रमन स्पेक्ट्रोस्कोपी के बारे में पढ़ेंगे। ठीक है, तो इन दिस स्पेक्ट्रोस्कोपी वी यूज लेजर लाइट। व्हाट we use laser light in Raman spectroscopy. As we know that in rotational and vibrational we talk about absorption and emission, but in this we will be talk about the scattering of light. So Raman spectroscopy is related to scattering phenomena. Okay, see, in this structure what we have is there is a molecule, and when an incident light of energy h mu falls on it, then three things can happen. Either it will give the energy with h mu, the whole energy will come out from after reflecting back from the molecule, and what can also happen, the molecule this molecule can absorb energy and we will get incident the scattered light of lesser energy. Okay, and what will happen, the third thing can happen, as this molecule, when the light of energy h mu will strike on it, this molecule provide energy to our light and we will get the scattered light of higher energy. ठीक है, तो two things can three things can happen, as we can get the molecule, we can get the scattered light with energy h mu, with less than h mu, or with greater than h mu. Okay, so see, if the incident and the scattered light have the same energy, then the collision is called elastic collision. On the basis of collision between our incident light and with the molecule, we distinguish it between in two words, elastic collision and inelastic collision. So if the incident light and the scattered light have the same energy, then the collision is called elastic collision. Okay, or if the photon's energy transferred to the molecule or the molecule transfer its energy to photon, the scattered light will have higher energy or lesser energy, then this is called as inelastic collision. So next we will see, when a radiation of frequency consisting of a stream of particles having energy h mu is made to collide with the molecules of substance, there will be elastic collision. It means there will be no exchange of energy between photons and molecule, as the incident light of h mu will strike on the molecule and give back a scattered light of h mu. It means there will be no loss of energy. It is called elastic collision. Whereas if there is a loss of energy or gain of energy, it is called inelastic collision, when the scattered light will be of same incident energy. This is called Rayleigh scattering. Okay, then if the molecule, see, if the molecule have 100 molecules, if the substances have 100 molecules and 90 of these will show elastic collision, 90 molecules will show elastic collisions, and the rest 10 molecules shows inelastic collisions. And in inelastic collision, the energy is exchanged between the photon and the molecule. Therefore the scattered photons have frequency lower or higher than the incident light. This is called as Raman scattering, and we have to focus on this part of our light. This, it is called Raman scattering. When the, see, if it is our molecule and the light of h mu will strike on the molecule. Okay, what can happen, either h mu will pass completely, and we get the scattered light with the same energy. Okay, or either we will get the scattered light, this molecule can give the energy to h mu, or it can lose the energy. So we will get light of higher energy or maybe lower energy. So we are interested in this area where we will get light of higher or lower energy, and it is called as Raman scattering. We have to note the point that Raman effect is a weak effect. It is a weak effect. So let's talk about Raman scattering. In this we get two type of lines. One is Stokes lines and other is anti-Stokes lines. When the lines when the energy which are after scattering, it will be lower. When the energy we get is lower, then we get Stokes lines, and when the energy is higher, then we get anti-Stokes lines. ठीक है, lines on the lower frequency side of Rayleigh scattering. if it is the energy if it is the line re- related to the Rayleigh scattering, then we get, see, in this structure, when the light of h mu strikes on the molecule, then it goes on the upper level and it comes back to the same level. So it means h mu light frequency, our incident radiation of energy h mu come back with h mu. So it is Rayleigh scattering. Okay, and see, when the molecule excited from energy level v is equal to 0 to any other energy level, okay, given with incident radiation h mu, so it comes back losing some energy. Okay, so it is called as Stokes line. We get Stokes lines in this case. And when in anti-Stokes lines the molecule are not present at our lower level, at v is equal to 0 lower level, they are present as higher levels, as like v is equal to 1 or v is equal to 2. So when sufficient, when light of h mu goes and we get back of energy h mu dash, okay, so here we can see the h mu dash is higher than h mu, so we get energy of higher radiation. So these corresponding to this we got anti-Stokes lines, right? From this we can learn one thing, that we can learn one thing, what it is, that Stokes lines have energy lesser than Rayleigh lines and anti-Stokes lines, means it has the lowest energy, whereas anti-Stokes have highest energy and Rayleigh lines have in between Stokes lines and anti-Stokes lines. Also, what we can see here, the molecules go in the higher level from ground state, and here from, not from ground state, from any excited state like visual to 1 or visual to 2 and higher. If we talk about the intensity, then here we can see, as the incident light and the scatter light have the same energy, so they have the highest intensity. So Rayleigh lines have the highest intensity. Now the question is, between Stokes lines and anti-Stokes lines, which will have highest intensity? So guys, what we can see here, that the molecules are present, population is maximum at ground level. So, and it will excite from the ground level, and whereas it will excite from v is equal to 1 at a higher level, from a higher level. So when the population, as the population is maximum at v is equal to 0, the lowest ground level, we will get intensity maximum here. So Stokes lines have higher intensity than anti-Stokes. Reason, you can see here, intensity of anti-Stokes lines is always less than Stokes lines, because intensity depends on population density. As population density is maximum in Stokes lines, so population density is maximum in Stokes lines, we will get intensity higher in Stokes lines. If you comparison com, compare if you compare about in between the energy, then Stokes lines have higher energy, then Rayleigh lines, and then anti-Stokes lines. We can see the wavelength comparison between these lines, as wavelength is reciprocal of energy, then it will be reciprocal of this. So we can say that in case of anti-Stokes lines, transition will be from excited state, therefore population is less, because we can see in this, the transition is from excited state, where it here transition is from lower ground state. Okay, so intensity is higher in Stokes lines than anti-Stokes lines, right? Moving next, now we will see a numerical here. The exciting line is this, given Stokes lines there k, and calculate the wavelength of anti-Stokes lines. As we know that the difference between the anti-Stokes and Stokes lines is same. Okay, then what we can do here, angstrom is given, we will find the wave number in terms of energy, we will find the answer in terms of energy, and we know the wave number है वो डायरेक्टली प्रोपोर्शनल होता है एनर्जी के, 1 बाई लैम्डा क्या बोलते हैं, वेव नंबर बोलते हैं. सो एनर्जी के डायरेक्टली प्रोपोर्शन होता है। तो हमने पहले इनको वी हैव चेंज इट इनटू एनर्जी टर्म in wave number. Okay, so first what we will get, we have to tell the delta E values, and we have given exciting line this and Stokes line। ये लाइन दे रखी है और ये लाइन दे रखी है, स्टोक्स लाइन दे रखी है, हमें ये लाइन निकालनी है। सो व्हाट वी विल डू, वी विल फाइंड this line we will add into this, we will get this value v of anti-Stokes lines। Okay, so you can see this example and try to solve it by yourself। I have told that energy of anti-Stokes lines is greater than energy of Stokes lines। Okay, energy of anti-Stokes lines is highest, then Rayleigh lines, then Stokes lines। Now we will come on rotational Raman spectroscopy। Raman spectroscopy includes two types of spectroscopy: rotational Raman spectroscopy and vibrational Raman spectroscopy। In rotational Raman spectroscopy, all the molecules are active and except spherical top molecules, and which are spherical top molecules, perfect tetrahedral and octahedral molecules। Okay, so all molecules are active in rotational Raman spectroscopy। Here we have this we know the in rigid rotor we have the formula for energy E is equal to B J into J plus 1, and we know that the selection rule for this for selection rule for rotational Raman spectroscopy is delta J is equal to 0 and plus minus 2। We focus on plus minus 2 because these correspond to Stokes and anti-Stokes lines। Okay, anti-Stokes lines, whereas J is equal to 0 correspond to Rayleigh lines। Okay, we know the distribution of PQR branch। For 0 we have Q branch, for plus 1 we have R branch, and in graph for plus 2 we have S branch। So here we will focus on S branch and O branch। As the selection rule is plus minus 2, so when J is equal to J is equal to 2, we will find out the delta E value। We will put the values 0 and 2 in this formula, E is equal to Bj into J plus 1, and we found that delta E value will be B4J plus 6, and we here J we will put the lower value between the J। Okay, so we get the delta E value equal to B4J plus 6। Now we'll find when our molecule is when the molecule is going from 0 to 2, level 0 to 2, then putting value 0 here, we will get delta E value is equal to 6b। Similarly, when del J is equal to from 2 to 4, we will get 14b, 1 to 3 10b, and 3 to 5 18b। Now if we make the formula for Stokes lines, then Stokes lines have the energy lesser than the incident line, this is the energy of incident line, we will minus it। Okay, delta E value will minus it, this we will get Stokes lines, and we will add for anti-Stokes lines। So the combined formula will be V is equal to V naught plus minus B4J plus 6। This is a graph for Stokes and anti-Stokes lines for delta J plus 2 and delta J minus 2, anti-Stokes and Stokes lines। Here we can see one thing, that this is the difference, the first delta E value will be 6b, here is the difference 6b, next will be 4b। If we have asked that what is the difference between first Rayleigh line and first Stokes line or anti-Stokes line, then we can see here that the difference between first Rayleigh line and Stokes or anti-Stokes line is 6b। Okay, this is the difference between first Rayleigh line and Stokes or anti-Stokes line। Then if we have asked what is the difference between Stokes and anti-Stokes line, so this is the first Stokes line and this is the first anti-Stokes line, this is the first anti-Stokes line, this is Stokes line। So what is the difference is 6b plus 6b, it will be 12b, so the difference will be 12b। Okay, so you have to know that the gap up to 0 will be first 6b, then 4b 4b 4b, equal gaps। Next question, the bond length of H2 molecule is given, we have to determine the position of first 3 Raman lines। Okay, we are given the bond length of H2 molecule and we have to find out the position of first three Raman lines. Now we have seen that it is the Rayleigh line. This is will the first Raman line, this will be the second Raman line, this will be third Raman line. We have to find out this one and this one. Okay. Now we can see the first line will be at at a distance of 6b. It is at 6b. Second Raman line 10b. Third Raman line will be 6 plus 4 plus 4. It will be at 14b. And we know the formula B is equal to h by 8 pi square IC, and we know we have given the bond length. We will find out I is equal to mu r square. Mu will find out, and mu r square, put the value of I in this, we will get B, and similarly we will get 6b, 10b, 14b as our three Raman lines. Okay, so try to solve it by yourself. नेक्स्ट इज इन द रमन स्पेक्ट्रम ऑफ लीनियर ट्राइटोम द फर्स्ट थ्री लाइंस, पहली थ्री लाइंस है उनकी वैल्यू दे रखी है, एनर्जी की वैल्यू, द डिटरमाइन द रोटेशनल कांस्टेंट मोमेंट ऑफ इनर्शिया. So just read the question very carefully. We are given the first three lines are at 4.86, 8.14 and 11.36. Okay, now see, this will be Rayleigh line at 0 1 0 1 2. This will be first difference. This will be 4b. First is 6b, then 4b, then 4b, and we have given the first three lines. We have given this line, this line, this line. As we know, the difference between two consecutive stroke lines will be 4b. So what we can do, we will find out that the value has been given, these two values have been given. We will find out the difference and we will put it as 14b. Del E value we will put it as 4b. Here, from here we will get the value of B. From here we will get I is equal to h by 8 pi square BC. From the formula we have got the value of I, and putting the values we will get our answer. As we have to find out, what we have to find out, we have to find that rotational constant and moment of inertia. From this we will find out. Now the next concept is effect of nuclear spin. If the molecule has center of symmetry and the nuclear spin is 0, then alternate Raman lines have 0 intensity. C for O2 and CO2, as the molecules have center of symmetry and their nuclear spin is 0, their alternate Raman lines will be missing. See, for O2 and CO2 molecule the even values are missing. जो even values हैं वो missing होंगे. जैसे here we can see this is a second line. Okay, 0 is missing. Okay, so if we want to say, we want to find out what is the gap between, what will be the first Raman line. So first Raman line will be 6b plus 4b, because the line at 0 is missing. Okay, so the first Raman line will be at 6 plus 4 10b. Next will be at 4 plus 4 8b. Okay, if we about find out the total at what 10 plus 8, it will be 18b, because the even values are missing due to presence of center of symmetry and a nuclear spin. Now the question on this is, if the in the Raman spectrum of 16 O2 molecule, we have to give in O2 molecule, it has center of symmetry है. The first three Stokes lines are separated by this. Calculate bond length. हमें bond length बतानी है, ठीक है. First three Stokes lines are separated. As we know, the even values are missing in O2 molecule and CO2 molecule. Then the difference between first Stokes and first Stokes lines, two consecutive Stokes lines, will be 8b. If it is 8b, we will find out the delta E value here, putting it to equal to 8b, and we will get the value of b. So subsequently we can find out the value of I, R naught, whatever we want to do, by using the formula I is equal to h by 8 pi square BC. We will get the value of R naught here. Now we will talk about vibrational Raman spectroscopy. As we know, the formula for unharmonic oscillator is E is equal to V plus half omega E minus V plus half का square omega E XC. And first we know that all the molecules are active in vibrational Raman spectroscopy. If we want to find out which of the following molecules are active in vibrational Raman spectroscopy, then we know that all the molecules are active in vibrational Raman spectroscopy. For an unharmonic oscillator, this is the formula for an unharmonic oscillator. Selection rule for the vibrational Raman spectroscopy is plus minus 1, plus minus 2, plus minus 3. Sometimes we can consider 0. Okay, so if we consider plus minus 1, then the formula for anti-Stokes lines will be V is equal to V naught plus del E. It will be del E, and we know that for plus minus 1 the value of del E will be omega E 1 minus 2xe. Okay, similarly for Stokes lines, energy will be decreased. We will get formula V naught plus omega E 1 minus 2xe. This value we get, delta E value we get from plus minus 1 only. For other, for plus minus 2, plus minus 3, we will get different values for del E. Now we will learn about the rule of mutual exclusive principle. If a molecule has center of symmetry, then its Raman active modes will be IR inactive, and vice versa. अगर किसी molecule में center of symmetry है, then its Raman active modes will be IR inactive, or its IR active modes will be Raman active. Okay, see, if the molecule, this molecule is given A and A, what we want to do, we have seen that this molecule has a center of symmetry, so its Raman active mode will be IR inactive, or IR inactive mode will be Raman active. If the molecule has no center of symmetry, then some vibrations may be both IR and Raman active. This rule is applicable only for those molecules which have center of symmetry. Okay, this is called rule of mutual exclusive principle. See, the CO2 molecule, it has a center of symmetry. Okay, so see the IR modes, in symmetric active, in IR it will be inactive. Asymmetric modes, in Raman they are inactive, in IR they are active. Symmetric bending, inactive, and in IR they are active. Whereas for H2, it is not for H2, because H2 does not have a center of symmetry. Okay, number of common bands for CO2 in Raman and IR is equal to 0, because their Raman active modes will be IR inactive due to presence of symmetry. Understand? Now we will do a question on this. There is a molecule A2B2. We are given the data. We have to tell that the molecule, the shape of the molecule. Okay, so in this molecule, see, it shows the strong band in Raman, but there is no intensity in IR. Okay, next it shows second absorption in Raman, not in Raman but in IR. Okay, so it shows the molecule has a center of symmetry. From this we can see that the molecule has center of symmetry. It means the molecule has center of symmetry. We have to make the molecule with center of symmetry, and here it shows very strong PR branch. If the molecule shows PR branch, then it will be linear molecule. See, if the molecule has PR branch, then it will be a linear molecule. Now we can see if we can make it in two ways. This molecule has center of symmetry, this also has, and both are linear molecules. So we have two answers for this question. Next is AB2 molecule. The data is given that it shows in IR it shows very strong absorption. In Raman it shows, does not show any, here strong, here strong. So it means that the molecule is not following rule of mutual exclusive principle, or you can say the molecule does not have center of symmetry, so we not use rule of mutually exclusive principle, because it does not have a center of symmetry. Because IR, it has strong IR band and Raman band also, so it means the molecule AB2 does not have a center of symmetry. Okay, also the molecule does not contain PR branch, so it is also non-linear. So our answer will be this A, B, B, as it shows the molecule in AB2 form, and it does not have center of symmetry. Also it does not have a PR branch, so it will be non-linear. So thank you guys, have a nice day.